We are on the section 2.3, Power and Some Rules, on your page 30. So we are going to start to talk about calculus. Calculus is really no big deal. What does calculus mean is just to calculate things, right? So counting things is one way to calculate things. So, but its method is kind of different. But just like you learn, arithmetics, then suddenly you learn algebra. There is a gap of thinking. Same thing from algebra to calculus. There is a gap of thinking. Totally different methods and different tools, right? Just like your cars, usually it was mechanical, now it's all electronical, right? So you just learn different tools to calculate things. So this portion, we are going to talk about power and some rules, just some way of doing calculus with rules, okay? So we are talking about power, so let's review some powers first. So we review the numbers. So we say 2 to the 0 is what? 1, right? Anything to the 0 power is 1. Then base is now 0. So 2 to the 1 is what? 2. 2 to the square is twice 4. 2 to the third power 3 times 8. That's a positive exponent. Okay, then let's talk about negative exponents. So 2 to the negative 1, we say this negative 1, negative doesn't mean negative. It means what? Reciprocal, means your fraction. So 1 to the 2 to the 1 power, which would be what? 1/2, right? And 2 to the negative 2 power would be what? Reciprocal. And 1, so you interpret this negative power become this guy, right? Then that would be 2 to the second power. So it would be what? 1/4, right? And 2 to the negative 3 power would be what? 1/2 to the third power, that will be 1/8. Those negative powers are just symbols. Then the value is this way, right? So this number actually represents the value of those fractions. We also have powers are different. Those are positive numbers. Those are negative numbers, integers, right? What happens if the power is a fraction? Then we say a to the 2/3 power. What does that mean? Okay, then we say that 2/3 doesn't mean 2/3. Those are symbols. The top one means what? A power. The bottom one means what? A root, right? So how should we interpret this one? So if you do the power, then you take cube roots. So a squared is what? 64. Then cube root of 64. Something multiply 3 times, and it will be what? 64. That's 4. Right? How do you use a calculator to do it? Okay, let's say this one first. Or we can do the root first. Right? Then you do the power. Then cube root of 8 is 2. 2 squared would be what? 4. Are they the same? Which number looks easier? A lot of time you will do what? The cube root first, right? The root first, then take the power, then make the number easier to manage. So if you use calculator to do it, how should you do? So A, usually this is a power symbol, or on your cell phone, it might be what? Y to the X or X to the Y, something like that. So then you do what? 2 third power means what? 2 divided by 3. Try that. See, you should get 4 as well. You need to get familiar with calculator. Okay? So we are reviewing what? The powers for the numbers. Okay? What happens if I have a 64 to the 2/3 power? Do you want to do the power of 64 becomes a very big number, then take a cube root? Probably not. You want to do the root first, right? Then take a square. That would be what? Cube root of 64 is 4, right? Take a square. So the value of this number means what? 16. Okay, what happens if we have this one? If we have 8 to the negative 2/3 power, what does that mean? So you need to interpret the negative power first, then you interpret the 2/3 power. So you will do what? 1 over 2/3, right? What is 8 to the 2/3 power? That's 4. So you should get what? 1/4, right? What happens if it's 64 to the negative 2/3 power? What would you do? Do the reciprocal to interpret the negative exponent first. Then you will do reciprocal 64 to the 2/3 power. What is 64 to the 2/3 power? That would be 16. So the answer equivalently would be what? 1/16. So we reviewed what? The power first. Then we start to do some calculus to calculate. Okay? Let's see some formulas. Okay? The rules you will follow. So first one we'll call it constant rule. What does constant mean? Something remain the same. It's a number, usually we call it a constant. Okay, so first one, the rule is dxc equals 0. Let's get back to the page 22, I think. Let's see. Section 2.2, page 26. And before we develop these rules, say we went through 2 dry sections. Something called what? Derivatives. Okay? So on your page 26, we talk about something called derivatives. So for calculus, the way to calculate, it use the rules and the thinking of the derivatives. Okay? We say a derivative of a function, right? it's according to a function, and at certain point of time, at here, right? We say, how was it defined? It was defined a certain way, right? It was defined what? F of x, f prime of x, okay? That's the symbol we were using. We say it's given by this way is what? F of x plus h minus f of x over h when h is approaching to 0. That means when it's very close to this point, right? Then what's your value of y is bounded by the difference of y, right? When the point h is very close to 0, that means we find the y value is bounded by certain thing, okay? So we use the symbol as what? F prime of x. We also said what? The derivative is the same thing as what? Instantaneous, oops, keep spelling wrong. Instantaneous, right? Rate of change. Also, it's the same thing as what? That means at this point of time, the f, the y, f of x, the y is bounded by this, okay? And at that time, what kind of change it would be? We call it what? Instantaneous rate of change. Also, it's the same thing as what? As the slope of the tangent line at the time. Okay, that's on your page 26. We talk about that. At the same time, we use what? Different symbols to represent f prime of x, right? We also, same page, we use f prime of x, right? Sometimes we use this symbol, d of x, d dx of this one, okay? And sometimes because f of x means what? Y. So we take a y prime, right? And f of x is y, so sometimes we write dy over dx. So we have different symbols. They all mean what? Same thing, something called the derivative. Then we are going to use the derivative concepts to do the calculus, to calculate things a particular way. Okay, so this is the new tools by a bunch of symbols and concepts we are learning. Okay, so then later on it becomes much simple, and when we just plug in the rules and formulas, then those are underlying the concepts to get to those rules. Okay, so let's come back to page 30. We say, here is the review. We are saying what? The instantaneous rate of change at x, at this point of time, right, is this way. And the symbols we use is what? One is this, one is this. Sometimes we use this way as well. Okay? So, we are going to introduce the first rule of this one. when we take a derivative of a constant, so that means what? This c is your f of x, which is your y equals c, right? What does that mean? If you graph y equals c, it means what? Say y is 5. Then here is, so constant means what? A continuous static state, right? So y is 5 is this line. And what do you think? So the derivative, y is from definition. We are going to show you how it gets here, okay? Another one from the concept, it says what? Is the, if my x, okay, say at the 2, my x can be 3, can be 2. So at this point of time, what kind of a change it will be at next instant? That will be instantaneous rate of change. What do you think? At this point of time to next point, it's going to change? It's not. So the rate of change, right? Instantaneous rate of change will be what? 0. At the same time, if we look the slope of tangent line, what do you think the slope? Horizontal line. The slope of the horizontal line is what? We say slope of horizontal line is what? 0. If it goes up, it's what? Positive. If it goes down, it will be negative. If parachuting, you don't have slope, we say it's what? Undefined or doesn't exist. So you can look by the concept of the constant. Constant means y equals some kind of number. It's a horizontal line. So by instantaneous change, rate of change, that would be 0. By slope, it should be 0 as well. So that's the concept, right? So that means my y equals a number, f of x equals number. Situation is this way. However, according to the what? The derivative of f at x, its definition is this way. It's a complicated one. But once we go over it, we are not going to use that anymore. But that's how the calculus started. Okay, so we trace back to the origin of the thinking. So if we use that, we say f of prime of the x means what? I'm going to use the limit, means this point, and what happened to the next point? This is x, next point will be x plus h, right? That means what happened to this one? When h is very close to the point, approach to 0, right? That means the next point is very close to the x. What happened to the point x at the time? What kind of change, what kind of behavior it will be? That's what f prime means, right? So according to this, then since what is the f of x now? Well, our f of x is what? C, right? So that means whatever x put in, you should get a C. Next point, 2 is 3, 2 is 5, 3 is 5, right? Everything, whatever x is, it will map to a constant state, C, a number. So this one is a C, right? Whatever you put in here, the result y is C. F of x means y. So that's f of x is c over h. H approach to 0, but it cannot be 0, right? So what do we have? C minus c is 0. I limit h approach to 0. That would be 0 divided by h. That would be what? 0 divided by h is what? 0. So it doesn't matter what h will be, how small, how big it is. The result is what? Limitation of 0, that's your y, say, right? What is bounded by the number, which is 0. Okay, so we use the original idea of the definition, the prime of what? F prime of x, right? Original definition of derivative. Then we get what? Result is 0. And this one, we use the what? The concepts of instantaneous rate of change and the slope of the tangent line. The result is still 0, right? Now, let's talk about using the rules. So this one is from definition. This one is what? From the concepts, right? Then, how about we use the formula? Formula says what? Formula says, okay, dx, derivative of the c. C is what? Your f of x, right? F of x equals c. You say the result is 0. That's it. That's what it's saying. Got it? So when you see, okay, if my y is this one, what's my f prime of x? Then you just say, okay, 0. So that's a see more example. Then you will kind of feel it, what's going on, okay, when we talk about a few more rules. Let's see the second rule. Second rule is what? We call it power rule. Okay? So after this, we are going to just use the formulas instead of going through all the original ideas. Okay? So power rule is talking about this. dx, right? That means same thing as f prime of x. So it is this way. So what does this one means is my f of x is what? X to the nth power. We are talking about power and some rules right now, the basic, how to, just like you add, subtract, multiply, and divide, then multiplication repeating itself is the power, right? So power rule is saying, so my f prime of x, it's the same thing as what? We write a different symbol as d over dx of what? F of x. Right? Then f of x is what? So we write the d of dx xn. That's what does this one mean? Okay? It says if you take a derivative of x to the nth power, it means what? You put n as a coefficient, then x to the n minus 1 power. You drop 1 power. So all the power property means what? Power rule means to whatever single variable to the nth power, you drop 1 level. Okay? So, but you put it, whatever the power is, you move to the front as your coefficient. Okay? That's what the rule says. Okay? Then, let's go to see some examples first. On your page 31. We don't need this anymore. We are going to just do the rules. Okay? So, on your page 31, we are doing what? Try to do the derivatives of power. So, first one, if my f of x is just 1 power, right? The rule says what? Your d dx of this guy, you drop 1 power, so it was invisible 1, right? So you will put the power in front of the variable, then you use the variable's power, drop 1 level. It becomes what? 1 times x to the 0 power. Anything to the 0 power is 1, right? So 1 times 1 is 1. That's what the rule says, right? And second one, if my f of x equals to the second power, what do you think? Drop 1 level, move the power to be a what? Coefficient, right? So you do d dx x squared, you put 2 out the front, right? 2, then drop 1 level, so that will be what? 2 to the x. Doing that is pretty simple. So all you have to remember is what? The rules. We just practice a little bit the original concepts of what? Limits. Okay? Actually, they can get the same result. We don't have to prove it. Okay? In regular calculus, you need to kind of verify what it is. But for us, we are going to apply it. So if it's a cube, third power, what should we have? Dx, right? Third power, so you move the power as a coefficient. Then x become what? 3 minus 1. So the result should be what? 3 to the x squared. That would be your answer. Okay? Then what happened to the negative power? Let's take a look. Okay? So if your f of x is x negative 1, that means what? It's the same thing as 1 over x, right? But according to this rule, what do? d over dx, x minus 1, you put the power as coefficient, then you will drop 1 level. Negative 1 drop 1 level, that will be what? Negative 2. So, oops, not here, coefficient stays. So, that would be your answer. And the negative 1, we don't need 1. So, that would be the answer, right? You see, we go through what? 1, 2, 3, 4, 5, or we'll go through 1, 2, 3, 4, 5, and on. Then we went through what? -1, -2, we can all use. What happened to 0? Right? So if f of x is x to the 0 power, what is x to the 0 power? It's 1, right? So if you do d dx x to the 0 power, which is 1, it's a constant. So you use what? Constant rule, so that will be 0. Got it? So what are we doing? We are learning the new skills with the formula, okay? With different formulas. Then we just use the rules to find its derivative instead of going through the limits thing. Then we are going to use this tool, new skills, to solve problems, even in the business world, okay? And let's figure out how it will be applied once we get familiar with all those rules, okay? Then next one, we are going to talk about the rule. It's called what? Constant multiple rule. Constant, right? Multiple rule. It's this one. So it says, okay, I'm going to take a derivative d over dx. Okay? Then you have constant multiplying your f of x. It says the rule goes like this. You can take this out, okay, constant. Then you take d dx, d over dx, take f of x. Then f of x, when you take it, that will be what? Take a derivative, that will be your f prime of x. That's what it's saying, okay? So we are back to page 30 and write down the rules. For the third one, it is what? Constant multiple, it's called what? Constant multiple rule. All right, let's see some examples. So let's get back to the page 31. We follow through those examples. So part 3, see how we are going to use the third rule. It just said, if f of x equals 2x, okay? So we say we are going to take a derivative for this, derivative of x, right? Which is what? d dx to x, right? It says if you have a constant, you can take a constant out. So you should have 2 outside d dx. If outside, it means what? Multiplication. If you take 2 out, then you will just do the derivative of x. What's derivative of x? We did earlier, right? You what? Drop 1 level, it becomes 1 outside, then drop 1 level of the power, becomes 0. Anything to the 0 power, so this one is any 1 minus 1, right? So if you take a derivative, so that would be x to the 0 power is what? 1. Then you multiply it by it, it becomes what? 2. look at the second one. What do you think? It's the same thing. So we have what? D over dx for 3x, right? Then you take a 3 out. That would be 3. Then you take a derivative of the variable for 1 power. And derivative of 1 power becomes 0 power, and just like that, right? It becomes what? Oops, x is gone. It's 1, so it's what? 3. Right? So we are learning what? 3 rules, 3 tools to do the derivative, right? It's the derivative rule tools we are using. So we are learning. So if I have this one, d dx 5 to the x cubed, variable and the constant. So you take a constant outside, that would be 5. Then you take a derivative of what? X cubed, right? Then what is your derivative of x cubed? That's 5. You move the power to outside as coefficient. Then drop 1 level, that will be what? X squared. Not too bad, right? So the final answer cleaned up. So that would be your answer. Look, the next one, d over dx 3 to the negative 4, right? This is what? Multiple of multiplying a number constant with what? A variable with power. Then we just use what? Constant multiple rule. Then put the 3 outside, right? Then we take a derivative of x negative 4. So how do we take the one variable with its own power? We use power rule. Drop 1 more level. Okay, put the negative 4 here. Then negative 4 dropped 1 level. That would be what? Negative 5. Is that right? Then we cleaned up. That would be what? Negative 12 to the negative 5th power. Not too bad, right? Okay, let's see the next tool we are going to learn. Go back to your page 30. It's called what? Sum and difference rule. Okay, so sum and difference, what do you think that is? Sum and difference, right? So we have what? 2 functions. F of x and g of x. We'll either add them together or subtract them together. When we take derivative of those, then what do? We just separate them. Each one you do it individually, then add them together or subtract them together. That's what the rule says. Okay, so let's see some examples on your page 31 and part 4. Let's do the first one. It says, okay, I'm going to take a derivative of these 2 things summed together. Okay, so what does this rule says? It says you just do it individually, then, right? and g, you do it individually, then put it together. So what you need to do is what? D over dx to the first one, and you do the second one. Right? What's the first one? The derivative will be what? Single variable with the exponent, right? We just use power rule. So move up to the front x and drop one level. That would be 2, right? Same thing for this one. Move to the front and drop one level. That would be it. That's what this rule is saying. Okay, pretty straightforward, right? For the next one, if we have 5x to the negative 2 power minus 6x to the 1/3 power plus 4. So we have 3 things as subtract together with a same variable with different powers. But we learn individual variable with power, we just use power rule, right? But first, we write it separately. That's 5x to the negative 2, right? This is a minus, so it's a minus d dx 6x to the 1/3, right? Then plus what? D dx to the constant. Then for this one, what do we have? So this one, constant and the variable, we use what? Constant multiple rule. So you move 5 outside, right? Then you take a derivative of x to the negative 2 power, which will be what? Negative 2x, power drop one level, negative 3, right? And this one, multiple rule first, then do the variable, drop one power. At the same time, move the power as coefficient. So x 1/3 minus 1, drop one level will be what? 2/3, right? Plus d dx of 4. Constant, you use constant rule, which should be what? A 0, right? Then cleaned up, so that will be what? Negative 10x to the negative 3 minus, do your fraction, right? That will be negative 2x to the 2/3, and 0 is 0. So that will be your answer. We don't change the fraction exponent to radicals or power anymore. We just leave it as what? Fraction form. Okay, exponent form. So that's the rule we are talking about is what? Sum and difference rule. Right? So let's get back to page 30 again. For the next tool, we are learning for something for exponential function. Okay? How we are going to do derivative. So many exponential function, we do the base e first. We are going to do this one first. So d dx, okay? So exponential, what does the exponential function means? It means what? Your variable is what? on the exponential position. All the previous one, all those are what? Polynomials. Remember, those we call it polynomials. Or negative exponents, we call it rational, whatever, right? Rational function. So, either polynomial or rational functions, and polynomial functions and rational functions. All those things, we use those. However, exponential function means what? Like 2 to the x, 3 to the x, e to the x power. Remember? We just reviewed it when we graph it. It's an exponential growth, right? We are talking about those. Exponential function, when x is on the exponential position, you cannot do things like those anymore. We say, when you take a derivative of e to the x power, the result is e to the x power. Why? Probably you don't want to know, right? We will use the limits, all those, original concepts to prove. Unless you are in the regular calculus class, you need to figure out. But for us, we don't have to know how to build the tool. We just use the tool. Okay? So that's this tool we are learning called exponential function. When we do the derivative, the result is the same. Another one is if it's this way, base is not e, a to the x, okay, it will be particular thing. But now right now, we will explain this later, okay? Right now, we just handle the basic one, e to the x power. And let's see how we are going to use this tool to see how it works. Okay, how it works. So let's come back to page 31. Where are we? Oh, okay. On the bottom, part number 4 over c. So we have d dx, 3 to the square root of x minus 4x to the 4th power over and 5e to the x power. Right? So this one just simple power things. This one is rational things, right? Fractions, things we call rational things. So this one is the what? Oh, not this one. It's this one. Exponential function. So first, what do? We separate them, right? We say as subtract. You can just use some difference rule. So we will write individually, right? 3, instead of using radicals or rational form, we are going to use all the what? Just with base with power. So square root means what? Half power, right? Minus 4x 4th is in the denominator, means what? Reciprocal, right? And this one is this. So first we change to what? The power form. And we will write them individually, right? First one and second one. Oops, where is the 4? 4 is still here, right? And the third term, we derivative the third one. right? Then we will use the rules, earlier tools to resolve it. So first one, number multiplied together, we use what? Constant multiple rule. So you take 3 out, right? Then d dx for this one, the power, we use power rule. Power rule means what? X to the exponent. Then you drop one level. Then take the coefficient out. So half, drop one level, half, drop one, will give what? Negative half, right? Then this one, take a number out. And, right? This one would be what? Drop one level would be negative 4 out from negative 4 becomes what? Negative 5, right? And this one, constant and multiple rule. Constant multiple rule. So you take a 5 out. Then you take what? Derivative of e of x. E to the x power. Then we will use what? The one we just learned. And exponential function e to the x to the power place. So it's itself. Then we cleaned up. So that would be what? 3 halves x to the negative half power. Then this one would be what? Second term would be 16x to the negative 5 power and 5 and e to the x power. Manageable, right? It wasn't too bad. So then we learn the tools first, and the whole idea is still what? We want to apply it. Okay, so we learn, is that all the tools we have? Oh, one more. Okay, so if you go back to your page 30, then you look at the next one. It's called what? Natural log. Okay, so how we are going to do this one, it means what? What is natural log? It's this guy, right? Natural log. And variable x. When we take a derivative, this one, it will be 1 over x. We are going to talk about this one later. Okay, that's on your page 30. So we practiced how to use those tools first. Then we see how we are going to apply it, and let's take a look what's the underlying meaning as well. Okay, so let's take a look the page 32, next one. So that's on our page 32. Then let's see what's happening. Okay, so we are still trying to practice the what? Derivative. Okay, so look at your page 32. On the top, it says f of x is this way. A function is a polynomial. It means what? A polynomial function. It says, let's find the prime. Something prime, which is what? Prime f of x, right? But it wants us to find f prime 2, and besides find the value, and also find its meaning. Why we do what we do. Okay, why bother with all those primes and what kind of meanings they are, right? So, first, you need to use your calculator or go to the website we talked about in the first, first class we talked about. Which side was it? Let me see. I wrote it down on your page 1, I think. So if you look at your page 1 on the top, we say, okay, you can use Desmos.com for 2D, 3D graphs. So you can go there. Or you can use calculator. You better practice your calculators as well. Okay? Just in case if we take a final in school, then in classroom, you cannot use your computer to graph or use your cell phone, go to the website. Okay, so you need to use a calculator. If you have problem using calculators, you can call me or you can go to tutoring center. So it's here is 1 and 2. Then if you use calculator, 3, 4, 5, 6, 7. Okay, so if you use calculator, you need to adjust your range, the window. Okay, so that's -5. And if you graph it, it will look like this. So if I plug in x is 2, I will get, if I plug in 0, I will get a 7, right? If I plug in x is 2, that's 8, 16, 16 minus 20, -4 plus 7, so that will be 3, okay? If it's to the cube, that means it will wiggle, turning twice, okay? Up to twice. Remember we used to graph what? X squared. Y equals x squared. That's your what? Parabola. So it looks like this, right? Opens up. So it only turns once, one level lower than the power. That's what it is, okay? So for the cube, it will turn up to twice. So we have the graph look like this, okay? If you use calculator, and you should graph it, look like this. You can just use Desmos.com to graph first, but you do need to practice your calculator, all right? So, and what will happen? So that's the graph, okay? Then it says find f prime of 2. So how should we do f prime of 2? So you find this first. So you do prime of x, take a derivative of this, right? That will be derivative of this would be what? Move 3 over, multiply, that's a 6. Drop 1 level, that's squared, right? For the second term, 2 move over, then 2 times 5 is 10. X to power, drop 1 level, is 1. Then for this constant, take that, it's 0, right? So that will be your f prime. Then f prime of 2 means what? You plug in the value to x. So that will be 2, 2, 4 times 6, right? So you plug in. So the value is what? It's 4. So what does it mean? That's the thing we are learning. So we say what? F prime at this point, it means what? Instantaneous rate of change, or it's what? It's slope of the tangent line, right? So if we look at the tangent line, is this way. Okay, the tangent line. The slope is what? Positive. Positive means what? It goes up, right? So f prime 2 means what? Means the slope at that time of the tangent line at that point at the 2, right? So it moves up. At the same time, we say is what? Is the instantaneous change at that point. That means at the point 2, it has tendency increase by what? 4, right? So it means what? It also means that the instantaneous rate of change at x equal, at this point we are talking about at time 2, right, is 4. That means at this point of time, you will what? Has tendency increase the value. Okay, then we actually seeing some business application, but from the number sense, we just try to see what does it mean for the number, how rapidly it will change. Have a little bit idea for the moment? Let's see the next example on your page 32. Second example. It says, in a memory experiment, a researcher asked the subject to memorize as many words from a list as possible in seconds. See how many words you can remember in a second, right? So, recall is tested. And then the subject is given 10 more seconds to what? Study. Oh, there's a typo there. And so on. Suppose the number of words remembered after t seconds of studying could be modeled by this. If you took stats, you know what this modeling means, right? You collect the data and you find the fit and you find the equation, a function. That's how we do. Otherwise, all those formulas, all those functions are collected by some people, like researchers. Okay, so they do that. And but for our class, we will give you those functions. So where's your variable? Variable is a base. So it's like a polynomial more, right? Instead of exponential function. So it's a function of what? T. So what does T mean? In this example, it is the second, right? The W means what? Words you remembered. Then he wants us to find the W prime 20 and see what does it mean, right? For the symbol sense, so if you want to find the W prime of 20, first we find the W prime of T. We take a derivative. Then we see what does it mean, okay? So you take a prime of this, so that would be what? You would do prime, take the constant out, then take what? Derivative of a power. So you do 2/3, the T drop one level would be what? 2/3 minus 1. That would be what? 1/3. Oh, Did I write it wrong? It's not 2/3. It was what? 2/5. Okay? So it should be what? 2/5 here. And 2/5 minus 1 would be what? Negative. Okay? Let me just write it so you remember. 2/5 minus 1. Right? So that will be 4 times 2/5 t to the what? Negative 3/5. Right? Then we multiply them. That will be a/5 t negative 3/5. So first we take a derivative. Then it asks us 20. So we plug in 20, right? Then use your calculator. So find the answer. 5t to the negative what? Oh, t is 20 now. 20 to the negative 3/5 power. Then you use calculator to do that. How do you do that? You a/5 times what? Do this first. 20 to the power, okay? Negative 3 divided by 5. You have to enter as such. Okay? So the number should be 0.2, around this number. Make sure you practice after you finish the video. Okay? Make sure you do that. Otherwise, you won't be able to do the tests. Okay? So, if you have problem using the calculator to get the numbers, okay, you can go to live chat at www.ukrainiancafe.com from our, tutoring site. So you from the ltcc.edu, and you can go to, I think it's virtual campus. Then there are links to go to our tutoring site. Then I think it's 9 a.m. to 4 p.m. Then you can chat with a tutor. They should be able to help you. They have whiteboard as well. They should be able to show you how to use calculator to get the right answer. You do need to know how to do that. Okay? So once you get an answer, then what do we try to do for the question? It says find and interpret. What does this W prime of 20 means? So it says, suppose the number of words, okay, remembered after t second. That means number of words you will remember after what? 20 seconds, right? So your interpretation is what? Your W is what? Measured in words, right? And T is what? In seconds we are talking about, right? So what the W prime means is what? Is what? W has what? Is the change at that time. Remember? It is what? Instantaneous change, rate of change, right? Has what? It's talking about the units. We are talking about how many words you will increase or decrease. Has such tendency at a time per second, right? That's the time we are talking about. So W prime 20, say, is this number. So what does it mean? Okay, it means that at this point of time, which is by these seconds. So that after 20 seconds, right, of studying, okay, so the subject is what? Learning about what? Not much. 0.27 of what? More words. Is that right? More words for what? Rate of change at that time has such tendency up or down, right? More. It's the changing part for each what? Additional second of studying, right? So how many words you can learn at the 22nd? So at the 22nd, you plug in 20 for how many words? It's learning, right? So you plug in here. So 4, then you 20 to the 2/5. You get this answer. That means at the 22nd, at that time, you can learn so many words at a time. But after that time, after 22nd, you have a tendency to do what? Learn a little bit more word, 0.27 words, 0.27 word at a time. So if you look at this question, it means what? At the 22nd of time, you plug in 20. So how many words you can remember? 13.2578 words about, okay? Then at the 21 second, you plug in 21 here. It means what? You can remember about 13.5190 words, okay? And what's the difference? It means 0.26 about. So that's what it's saying. At 22nd point of time, if you study a second more, you can remember how much more words? 0.27. The rate of change, how many more you can remember at that time. So that's how they did the memory experiment. That's the derivative, the rate of change. That's what it means. Okay? Let's see some applications. On your page 32, on the bottom, we are going to talk about marginal cost, marginal revenue, and marginal profit. If you take some business class, right? If you take some classes on business, then you would have learned something called marginal cost, marginal revenue, and marginal profit, right? So we say marginal cost is the derivative of cost. That's the mathematical thinking of the derivative, okay? What does derivative mean? Derivative means what? If we take, let's write down the symbols first. So we use this symbol, marginal cost. of x, right, is what we call c prime of x, is the derivative of the cost. And that's mathematically speaking. And let's see. We say the derivative, it means what? The derivative of cost, it means it is what? It's an instantaneous rate of change. That means at that moment, what kind of change it will be about the cost. That means your cost will be increased or decreased. Okay, so it means what? The cost or cost to produce, okay, one more item at a time, right? One more unit at a time. At that instant. That means marginal. At that margin, at the time, if you produce one more unit, how much it will cost you. Okay? Then marginal revenue, same concept of that, is what we call the derivative of the revenue. So we use this symbol, right? Marginal revenue. Okay, so UX is what? It's your unit. Then unit, the revenue for the units, right? About marginal at a time, then we will take a derivative. Then we say the meaning of derivative means what? The instantaneous rate of change. The change of the revenue when you produce one more unit. Okay? So it means the revenue, right? Sometimes it's gain, sometimes it's loss. Okay? When one more unit is produced at the time, at that instant, right? At that instance. So it's the rate of change. The change is caused by the what? One more unit. So we call it what? Marginal. Okay? Then same concept we use for the profit. Mathematically, we say, okay, we use this symbol, marginal profit, right, is what? Take a prime of the profit. Because when you take a prime, it means derivative. It means what? The instantaneous rate of change at the time. And for the instantaneous rate of change means what? At that instance, then when you produce one more unit, and what kind of change that would be, right? So it means what? It means the profit, the change on profit, right? The profit, and you gained, okay, when one more unit is produced at the time. Does that match with your business class? You have learned about marginal profit. When you produce one more unit, then what kind of a profit you will gain marginally, right, at the time, which is same meaning of our math on what? The prime, right? Taking the derivative. So, at the same time, you would have known already. So, what's the profit? So, your profit is what? Your total income revenue minus what? Your expense, right? Revenue minus expense. That would be your profit, right? So what are we doing? We are matching the math method and concepts of the derivatives with your business definitions of marginal things, right? Marginal costs, marginal revenues, or marginal profits. They have same concepts, right? So let's see some examples. On your page 33 example, it says finding and interpreting marginal cost. The Pocket EZC is a miniature kitchen flashlight based on LED technology. The cost function, the total cost of producing X flashlights, is this way. It's given to you, say, okay, this is the function. So first you need to figure out what is X. Here, X means what? Number of units. How many flashlights are produced? Okay? Here's a C is the dollars and X is number of the flashlights. So let's look at examples and the question. First one, it asks you compute the cost of producing 82 units of flashlight. Second one, compute the cost of producing 82nd and not 82. Okay, should be 82nd, like 82nd airborne division. So units of flashlight. I copied from somewhere, I guess. Okay, so you look this function, then you are wondering, what are they talking about? Okay, the cost function, C of X, is what? It says the total cost of producing X flashlight. That's what it is saying. Okay, so let's just do some analysis. So you have job like business analyst, system analyst, right? Financial analyst, this type of job. So what do we mean by that? If you have a function, how about you just plug in? Then see, what does it mean? So if you plug in X equals 1, means what? If you produce one unit, one flashlight, how much it will cost you, right? According to the function given. So you're plugging for 1 to the third power plus 300, okay? Then if we do that, that's one will be $308, right? I'm going to just plug in another number, a good number, 16, because I can take a what? 4th root, right? So 4th root of 16 is 2. 2 to the cube is 8. 8 times 8 is what? 64. So that will cost you $364 to produce 16 flashlights. Right? That's what the function means. The total cost. Okay? So first question is asking to figure out the total cost of what? If you produce 82 units. So what do you do? What do you need to do? You just plug in your 82, right? So your x is 82. You plug in, and you have this 82. Take a cube, take 4th root, directly plug in the function. Then you use your calculator. Then to figure out, it will be 5179969, something like that, right? But for the money, we do what? We round it to the pennies. So that would be $518, right? So C of 82 is telling you it will cost you $518 to totally produce 82 units. Then let's see the second one. And second question is asking you how much it will cost you to produce this 82nd one. It's not total 82 of them, right? So cost of 82nd unit, right, is what? That means total cost of 82 units, right, minus total cost of what? 81 units. Is that right? That would be your 82nd units. So total cost of 82 units, we know is that one, $518, right? And total cost of 81 units, that would be, you plug in, so that would be C of 81, right? You plug in there, then that would be what? For this one, that would be, you plug in to the number, right? Plus 300, that would be 516. So you do 518 minus what? 516, that would cost you what? $2 to produce the 82nd one. Is that right? That's the function telling you. Okay, that's how you apply to the function to figure out what kind of numbers they are. Right? So let's take a look. The next question. It says, find the marginal cost of function MC of x. We say marginal cost function is what? Take a derivative of the cost, right? Because derivative is the marginal. Same concept, right? So if you take a derivative of C of x, that means what? You take d of dx for this function, right? So which is what? That guy over there, right? That would be, let's just write it as a, okay, let's just write it out first. Then we take a derivative. Then we will rewrite it as what? Exponential, right? Thing with exponents instead of radicals with power. So that will be 8x to the what? Top is power, bottom is the root. So we change that to exponents. Then we take a derivative of this. Derivative of constant is 0, right? Constant rule. Derivative of what? Multiple with constant. Then you take a derivative, take 8 out. So then you take a derivative of this, which is what? 3/4, right? X 3/4 minus 1 is what? Negative 1/4, right? Then we simplify. We have what? 6 and x to the negative 1/4 power. So that's your derivative of c of x, cost function. At the same time, it means what? Marginal cost, right? According to this marginal cost, then if I wanted to find what? Marginal cost when 81 flashlights have been produced, and interpret your answer. So it's asking you, let's do it first, okay? Find the marginal cost when 81 flashlights were produced. So what do? You plug in MC 81, right? So you plug in here, that means plug in here. Add 6 times what? 81 to the negative 1/4, right? You can use calculator or you can use your brain. So it means what? Reciprocal. 1/81 to the 1/4. And it means what? 1/4 means what? Take the 4th rule, right? Which is 6 times what? That's 3, right? Times 1/3 means what? 2. It means what? Marginal cost for 81 is what? $2. And what does marginal cost mean? It means it will cost you $2 to produce one more unit after you produce the 81 flashlights, right? That means that's the marginal cost. So interpretation means what? When you produce the 81 flashlights, okay, once this one have been produced, then marginal meaning is what? It will cost you about $2 more, right? $2 not more, $2 to produce one more unit of flashlight, right? That means what? To produce one more unit after 81 units were produced. That means what? That is which the unit we are talking about, 82-second unit, right? Will cost about $2 to produce. That's what it's talking about. So, what are we saying? We are saying one way to look at the marginal cost from the cost function, it will cost you $2 to produce for the second 82nd unit. At the same time, we can use, just from the concept of the cost function, if we want to find the 82nd unit, then of course all you have to do is total 82 units minus what? Total 81 units. That will be your cost. But we are using what? The new concept we have to do the problem. It has a certain purpose later on, you will find out. This one we can just use directly with the regular concepts to do that. Let's see something called demand function. What is that? Right? So, in business world, let's talk about what is demand function. We say, on your paper, we are on page 34. On the top, it says, the demand function is such way, okay? It is a relationship between the price P of the item and the quantity Q that consumers will demand at that price. That means at a certain price, what kind of demand would that be? Okay, so it means what? Demand function, it means if consumers, right? Consumer, let me see. Okay, consumers demand Q units the price will be P at the time, okay? It's kind of confusing, isn't it? Oh man. So let's see. Okay, so I would think I would do another way around instead of this way. It means what? Okay, if, all right, people want to buy, say, 100 units of, say, pizzas, right? Then if you have 100 pizzas, then the demand will be at the price, say, okay, $7 per piece. If you have so much demand for 100 pizzas, then price will be at the P. I will use the second one. It's kind of more reasonable, I would think. So it would say, if the price is such a way, is P, then consumers will demand Q units at the time. So if, okay, the pizza price is $7, okay, then the demand will be what? 100 units. Does that make more sense? But actually, it's the same thing. If you, okay, there is 100 units of demands, 100 pizzas are needed, then the price will be P dollars. Okay, so this one is what? The demand quantity is according to the price of P. It's really hard to explain. See, we can connect it to it. Okay? So, what it's saying is, demand function is what? The relationship between the price and the quantity. If, what do you think? Price is low, right? The quantity will be high, because if you sell cheap, then you will be more demand, then people will buy more, then quantity will be high. If quantity is low, then if I sell only a few items, then my price will be very high. So they are related to each other. So you can write either way. Price is what? According to Q, and or the quantity is according to P. That's what it's saying. Okay? And also the total revenues. So we can write it this way. For total revenues, total number of items sold, okay? So revenue according to quantity sold, right? So the revenue is what? The price you sell times the quantity sold. Then that will be total revenue, right? So that will be what? Quantity, is that right? So we can do either way. Quantity times P, okay? Because we are talking about variable with the quantity. Then price is according to quantity, so we can write it this way. A little bit abstract right now, okay? So that's the revenue according to what? Quantity sold, right? And total revenue, or we write the total revenue with X, that would be X times what? D of X, right? Same thing, quantity, then times what? Demand. So if you use quantity as your variable, your demand of quantity will be your price, okay? Then if total cost is C of X, how much it costs you to produce 100 pieces, say. Then your profit would be what? Your profit would be your revenue minus what? Your cost, right? So that's just the formulas and thinking behind the revenues, cost, and what? Profits, right? So we are talking about demand function. Let's see some examples. Maybe that will help a little bit. Okay, so we are saying, usually I will use this, right? The quantity, the demand, how many quantity would be needed according to the price, I would think. But in the meantime, we can also think, okay, if we have more quantity demand, then the price would be lower, right? Same thing. So you can think either way. Then for the practical purpose, actually you can do either way, okay? When we do some examples, you find out either way will work. So let's take a look for the example. Okay, on the page 34, right? It says that the demand function for a product be given by the function of such. Okay, so it use what? demand by quantity, then that will be the price, right? From here. Usually you would think if demand quantity is high, then price would be lower, right? For the quantity. And if demand quantity is given this way, what do you think? Actually, this is the price. That means what? Dollar, right? So you look at this function, it means what? Find something. It means if you have a more quantity, right? More quantities, then the price would be lower. That's what it's saying, right? So Q is the quantity of items in demand, right? D of Q is the price of the item in dollars. They can be what? Charged when units are sold, okay? And suppose fixed cost of production for this item are $2,000 and variable costs are $10 per item produced. If 32 items are produced and sold, find the following. Let's follow through and it will make more sense then, right? Let's see. The total revenue from selling 32 items. So we say revenue is what? According to quantity you sold, right? However, the price will be impacted by how many quantity sold according to this. So we use what? Revenue, since we give what? Demand function is function of Q. So what we are saying is demand function can be function of the quantity or function of the price. Okay, since it's given this one, so we will use what? We will use the price will be D of Q. That's what it is saying. Okay, then Q is your quantity, then P will be your price. Right? So, what's the revenue? First question, the total revenue from selling 32 items. So according to formula, this one, so your quantity revenue is what? This, how many quantity you sold with the price. Then price will vary according to the demand of the quantity, right? So now we have what? We have Q is this, D of Q is that, so it's this one. Mathematically speaking, right? So the question is, what's the total revenue from selling 32 of them? So your quantity is 32. So you plug in 32, right, to here. So that's your quantity. Then that's your price. 32 of them, right? Plus 210. So that's your price when you sell 32 items. Then plus times 32 items. So you will have 4825.60. Okay, that means the revenue for 32 items would be $4,800, something that way. right? And that's C. Then for the B part, it says the total cost to produce 32 items. Where is your cost function? Do we have it? What do you think? What do you think how much it costs you? Take a look on the top. It says what? Suppose fixed costs for the item are $2,000 and variable costs are $10 per item. That means you have to rent a place or machine. It will cost you $2,000, and each item will cost you how much to produce? $10. So your cost function is supposed to be what? $10 each times what? Let's use Q, okay? Times Q, how many items you sold, you produced, then plus fixed cost 2,000, right? Now we sell what? How many items? 32, right? So we produce 32 of them, so you will times 32 plus 2,000, so that will cost you $23.20 to produce. Okay? Then let's look at the next one. What's the profit? So profit is what? Revenue minus the cost. So that's relatively straightforward. So it's equals revenue minus the cost, and so equals what? You do 4825 minus 2320, so that would be what? 2505.60. So that's the profit. So what do we try to do on this example? What do we try to learn? So we are learning what? Demand function. The price is depending on the demand of the quantity. Same thing as quantity is a function is related to what? The price. Right? The rest of them, the revenues and profits and costs, that's just a standard. How many items you have, how much you sold for, then that would be your revenue, right? Then cost function is what? How much each cost, then times how many items you produce, then plus the fixed cost. Is that right? Okay, so we are learning what? Demand function. Actually, if demand function D of Q, so it's the same meaning as the price. Okay? Let's see some more examples. Hopefully, you will get better on demand function. So right now, we are using price equals what? Demand of quantity first. Sometimes we use this one. Are we kind of okay? Okay. Let's see next example on your page 35. It says, suppose your demand function is given by, okay, your demand function, if you sell so many quantity, then the price, demand function of the Q, that would be your what? Dollar, that would be your price, right? Is given this way. Then Q is thousands of units sold. And D of Q is the price. So Q is the quantity in thousands units. Okay? Ask you to find out the following, showing all calculations clearly. Okay, let's just follow through, see what happened. So it says if 18,000 units are to be sold, what price should be charged for the item? If you can sell 18,000 units, what kind of price you think you will charge the customer, right? Second one, if a price of $451 is set for this item, if I want to sell the item for $451, how many units can you expect to sell? Okay. Next, problem C, it says at what value of Q does D of Q cross the Q axis? We figure out what are they asking. Okay, so for the first one, it says if 18,000 units are to be sold, what kind of price you will be charged, right? So according to the demand function, if my demand for the Q is 18,000 units, but I don't use 18,000 because Q says this function is what? By thousands. So I should use what? 18. 18 means 18,000, right? Then the price will be what? Price is according to your demand of the quantity, which is Q. Then according to the, say, prediction of the demand, according to somebody, they studied it according to that function. So you will plug in 18 to the square minus 2 times 18 plus 531. Okay, so that would be D of Q. Q is 18 right now. So when we plug in, so it ends up 171. What is 171? Is your price, item price. That's what it means. Okay, so next one. It says if a price is $451, okay, if I want to sell the price instead of 171, when the demand is so high, I can sell this price, right? But if I say, okay, so if I want to sell GoPros, so I say, okay, I can sell $171 per piece if I have 18,000 demand, right? However, if I say, okay, I just want to sell each one for $451, and what kind of demand I expect to have, that's what it means, okay? So we want to find the Q. If I sell $451, you may not have 18,000 customers. So if I sell this price, then how many customers it might be, right? So what do? You plug in here, that's your 4051, that's your price, right? Equals this function. Then what do we have? We have what? Quadratic equations. Is that right? So we move everything to the left-hand side, write in standard form, right? You do on both sides. Okay, so what do we have? Q squared plus 2Q and minus 80 equals 0. Then you do your factoring. That would be what? Two numbers multiplied together is negative 80. Added together is 2, right? That would be what? 10 and 8. That will work. Plus 10 minus 8. Is that right? Yes. So what do we have? Q can be what? Negative 10 or Q can be what? 8. So, do you think you can have a negative number? Not really, right? Quantity, you cannot have a negative number. So you can only use 8. What does 8 mean? 8 units? If you sell for 51 per piece, you sell 8 units? Not really, because we say Q is what? By thousands. So actually is what? 8,000 units you will expect to be sold. Got idea? If the price is a function of the quantity, so the price varies according to how many quantities are in demand. Okay? So, if we look from mathematical point of view, from the algebra you have learned, okay? So we say it's like this. You see, we say y equals what? Y equals f of x, right? That's your y, that's your x. But now we use what? Demand of quantity equals price. So price is in terms of your y place. So that's your price, and this is your quantity in demand. Okay? Then we have what? We have that one, so it's what? P equals negative Q squared minus 2Q plus 531, right? So leading coefficient is negative. It means what? Opens up or opens down? It opens down, right? So if you sell what? Demand is 0, okay? The end up P is what? 531, okay? So that would be here. This is a 531. Okay? Then it opens down and it's a parabola. So the curve look like this. Right? Then how about the point here? It means what? Price is 0, quantity is so much. But we will never do that. Right? So for this point, it means what? 0 equals negative Q squared minus 2Q plus 531. Okay? Then how do we solve the Q? Here, if you do, quadratic equation, Q equals what? Negative B plus minus square root of what? Let's just write it down. Negative B plus minus what? B squared minus 4AC all over 2A. Is that right? That's in your 152B class. Right? So we are just kind of doing the analysis for the problem we have. Okay, so we just see what's going on. So we plug in your A is what? A is -1, B is -2, C is 531. Okay, so you plug in that. So what's your Q? So we just solve the quadratic equation. So the Q is about, okay, so Q, we plug in the number -2 plus minus, okay, I'm just copy down those number for A, B, C, right? Then 531 and over 2 over -1, right? Just copy in A, B, C. So it ends up about, okay, it's 2 plus minus, you do your math, 1302503.8. I just give you the answer. So it's about, okay, these two numbers. So we have Q equals what? -24065 or 22 over 65. We have these two numbers. Quantity cannot be negative, so quantity is what? This one, 22065. But it's what? By thousands units, right? So you times that thousand, so this number is what? 22065. So what does that mean? It means if P price is 0, if you give away, say, okay, $0, okay, for free, that would be about so many units, okay, will be in demand, it has so many people will love your free giveaway. That's what it means. Confusing enough? Okay, so do the homework, practice a few, it might start to make sense, hopefully, right? That would be our section 2.3.